Last week, we learned about the magnitude and direction of vectors. This week, we're learning about the argument and modulus of complex numbers. The argument is the same as the direction, and the modulus is the same as the magnitude. In this video, we will be talking about complex numbers and their modules and arguments. The line segment, OP, is the modulus of the complex number in this diagram. The angle from the positive axis to the line segment is called the argument of the complex number, which is shown as z in the diagram. In this diagram, the y-axis is replaced by the I-axis, which is the imaginary axis, and the x-axis is replaced by the real axis. This is because complex numbers are written as x plus yi. Real numbers and imaginary numbers are examples of complex numbers. There are also complex numbers that are not real or imaginary. They are just complex. On the diagram, x plus yi is a point going x number of times over on the real axis and y number of times up on the I-axis. For example, you could find the modulus and argument of z equals 4 plus 3i. This point is represented by q. To find the modulus of this complex number, all you have to do is use the Pythagorean theorem. You just plug in the side lengths and solve for c. And the number that you get for c is the modulus of this complex number. Now we're going to solve for the argument of this complex number. You can use tangent equals opposite over adjacent to solve for the angle. You plug in the values and solve for theta. You can do this by solving for the inverse, the number that you get as the argument of this complex number.